So in this video we will talk about a very important result, which is that if we have two numbers a and b, then their product, this is equal to the product of their GCD times their their LCM. Okay, so in order to prove this, so first of all I want to start with a very simple observation, not a result but just an observation, that if you have two numbers I and j and you have to say minimum of them plus maximum of them, so is this equal to I plus j? That's the question. So now if the minimum of them is j, then maximum of them should be I, and if the minimum of them is I, then the maximum of them should be j. So in both cases, this sum, minimum of two numbers plus maximum of those numbers, is equal to the sum of two numbers themselves. Now let's see how we can apply this to the result we want to achieve. So first of all, let's say what is GCD of two numbers. So GCD of two numbers, this is equal to what? Now let's say a is some integer which can be written in its prime factorization form, p1 x1 p2 x2 up to pn xn, and b is some number which can be written as p1 y1 p2 y2 up to pn yn. So what is a times b? This is equal to p1 x1 plus y1 p2 x2 plus y2 up to pn xn plus yn. Okay, so this is our first results. We call it equation 1. Okay, now let's see what a GCD is. What is GCD of a and b? So this, by definition, this is equal to p1 minimum of x1 y1 p2 minimum of x2 y2 up to, this is a product, so pn minimum of xn yn. Okay, now let's see an example of this. So for example, we have to say GCD of okay, try to give me some numbers, 40 and let's say 28. Okay, the answer is 4, we know that, but let's write 40 as, what is the prime factorization of 40? 2 times 2 times 2 times 5, which is equal to 2 cube into 5. Okay, and then what is 28? Prime factorization is 2 times 2 times 7, which is equal to 2 squared times 7. Okay, so then because we have two different factors, 5 here and 7 here, so what we do, we say 5 to the 1, 7 to the 1, and we say 7 to the 0 and times 5 to the 0 here. Okay, so the GCD of 40 and 28, this is equal to 2, minimum of 2 and 3 is 2, times 5, minimum of 0 and 1 is 0, times 7, minimum of 0 and 1 is 0, which is equal to 4 times 1 times 1, which is equal to 4. Okay, now you must have guessed now that the LCM of a and b is just the same thing with minimum replaced by the maximum. So LCM of A and B, where A and B are again written in prime factorization form, is equal to P1 maximum of x1 y1, P2 maximum of x2 y2 up to Pn maximum of xn yn. Okay, so then let's see an example again. So LCM of 40 and 28. What is the LCM, by the way? I think the LCM is 280, but let's see, I may be wrong. Okay, so 40 again is what? 2 squared times 5 to the 1 times 7 to the 0, and 28 is equal to 2, no sorry, this is 2 cubed. It's 2 cubed. Okay, this is 2 squared times 5 to the 0 times 7 to the 1. Okay, so my LCM is, what is the maximum of 2 and 3? 3. What is the maximum of 5 and 1? 0 and 1, which is 1. Which is the maximum of 1 and 0, which is 1, which is equal to 8 times 5 times 7, which is equal to 280. So I was right. Okay, now let's see what is GCD of AB times LCM of A and B. This is equal to P1 minimum of x1 y1 plus maximum of x1 y1, and then take the product up to, I'm skipping P and P2 now, it's obvious, it's so this is xn yn, so this is all up multiplied by P2 to the power of this minimum of x2 y2 plus maximum of x2 y2 and so on, so up to plus maximum of xn yn. So now where did we start from? That minimum of x1 y1 plus maximum of x1 y1 is what? Just x1 plus y1. So this is equal to P1 x1 plus y1, P2 x2 plus y2 up to Pn xn plus yn. So this was what? In our equation 1, this is equal to A times B. So we say by equation 1. So thus we have proved that the product of any two integers is equal to the product of their greatest common divisor, which is GCD, and least common multiple, which is the LCM. So this is it for this video. Thanks for watching. Hope you like it.